expand the function sin x in powers of x minus pi by 2 in Taylor series. From Taylor series, we know fx is equal to f of a plus x minus a divided by factorial 1, then first derivative of the function at x equal to a, then x minus a whole square divided by factorial 2 into the second derivative of the function at x equal to a, similarly for third derivative, nth derivative. And here we have to find out the powers of x minus pi by 2. That means we have to find out the value of the function, sine function, and here x equal to pi by 2. And in this equation, if you substitute the a value is equal to pi by 2, then the powers will be x minus pi by 2 to the power 1, x minus pi by 2 to the power 2, x minus pi by 2 to the power 3, like this. That means we can easily expand the sine function in powers of x minus 2. So here the a value is equal to pi by 2 and the function is your sin x. So Taylor series is an expansion of a function in power series of x minus a. Here this is for the general, and if it is given like this, then the power you can represent the function in powers of x minus pi by 2. So the function is given fx is equal to sin x and a is equal to pi by 2. So what will be fa or f pi by 2? If you substitute the value of x here pi by 2, then sin pi by 2 is equal to 1. Then you find out the first derivative, second derivative, third derivative, fourth derivative to find the successive terms. So what will be the first derivative of the function with respect to x? That will be equal to cos x, and we need to find out the first derivative of the function at x equal to pi by 2. So if you substitute here pi by 2, then cos pi by 2 will be equal to 0. Similarly, the second derivative of the function, sine function with respect to x will be equal to, you differentiate this function with respect to x, that is minus sin x, because derivative of cos x is equal to minus sin x. Then the second derivative of the function at x equal to pi by 2 will be equal to, if you substitute here pi by 2, that will be equal to minus 1. Similarly, you can find out the third derivative will be equal to minus cos x, and the third derivative at x equal to pi by 2 will be equal to minus cos pi by 2, so it will be equal to 0. Then you can find out the fourth derivative, fifth derivative, like this. Then after finding out the first derivative, second derivative, etc., you put the values here. This is the first term fa, that means we have found out f of pi by 2 equal to 1. So f of pi by 2 is equal to 1 plus x minus a is here pi by 2. So x minus pi by 2 divided by factorial 1 into f dash x. What is f dash a? F dash pi by 2 is equal to 0. So this is 0. The next term is x minus pi by 2 whole square, because x minus a whole square. So x minus pi by 2 whole square divided by factorial 2. And what is a double dash pi by 2, that is equal to minus 1. So here it is minus 1, the second derivative. And the next term is x minus pi by 2 whole cube divided by factorial 3. And what is the third derivative of the function at x equal to pi by 2, it is equal to 0. Similarly, you can find out the next term, that means the fourth derivative, fifth derivative. And if you rearrange the terms, first term is 1, the second term is 0, minus, there is minus, so minus x minus pi by 2 whole square divided by root 2, sorry, factorial 2. Next term is 0, this term is 0, and the next term it will be equal to x minus pi by 2 whole to the power 4 divided by factorial n. So in this way, you can expand the sine function in power of x minus pi by 2. By using Taylor series, you can expand the function, sine function in the power of x minus pi by 2. Thank you.